number 10. So we have the ordered pair 5, 2. We have the ordered pair 5, 6. Three, -2. And 0, -2. The list of ordered pairs that's on number 10. Now, the directions on number 10 actually ask us to express each relation, okay, and that list of points is a relation. It says express it as a table, a graph, and a mapping, then determine the domain and range. We're just going to do the domain and range right now. That's the skill I'm most concerned with at the moment. So, write down what you're going to do. Find domain and range. Yes, sir?
What's the right on new sheet paper or that note that we got third day?
I would probably do that I'd probably do it on a new sheet of paper, but it's okay if you do the back of that. Now, who can remind us, okay, from the pre-AP handouts that we've had, what the domain means? We've talked about domain a few times there. Okay, Ty?
And domain is your X.
Domain is the X. What were you going to say, Tyler? It is also the independent variable. Okay, so we have a list of points here that are x, y points. Okay, the first one's always x, the second one's always y. So if we're going to list the domain, we're going to list all of the x values, all the independent variables. Okay. So for this problem, we're going to write ourselves a note underneath that just says list all x's. Not as in all my x's live in Texas, but all the x's from the coordinate plane. Okay. And we're not going to repeat anything. So write yourself a note that says no repeats. No repeats. Right. So we have a 5 and a 5, but we're only going to write that down one time. Now, I don't really, well, I do know why. Typically, we list the domain in these braces, okay? I know they're hard to write. Just write a squiggly line if you have to, because it's the set of all points, okay, that are in the domain. So we have a 5, a 3, and a 0. Granted, the 5 shows up twice, okay, but we just write it down once. We're just listing all the numbers that are used, not how many times they are used. And then what do you think the range might be? All the y's. So you're going to hear me say over and over for the rest of your life, the domain is x and range is y. Because if you can remember that, it'll help with a lot of stuff. Definitely write down the negative. Just don't write down -2 twice. So you write down the +2 and you write down the -2 because those are two different values.
Isn't the range the lowest number to the highest number?
That's a good question. In math, we use the term range to mean two entirely different things. Okay. So in the context of statistics, with mean, median, mode, and range, then yes, the range is the difference in the lowest and the highest number. In the context of relations and functions, it's the list of all the y values or all the dependent variables that could come up. Again, no repeats. So we have a 2, a 6, and a negative 2. Don't leave off the negative 2 just because there was a positive 2. Those are two different values, so you have to write both of them down. In your book, you're probably going to see them listed in order from lowest to highest. I'm not really concerned with that necessarily, just as long as the numbers you have match the numbers they have. Okay? I'm not picky about the order. So the answer there would be the list of the domain and the list of the range. Turn to page 44, to the next page, and look at number 28. Okay. It says in the directions to express each relation as a set of ordered pairs, describe the domain and range. So we need to first list all of the ordered pairs for all those points that we see there, and then we can do our domain and range. So I'm going to start from the far left, okay, the one that's on the top left, and work my way to the right. So the list of all the ordered pairs, I'm going to put my braces. Okay. So the point that's on the far left, if I start at the origin and count left, it's 2 to the left, which is a negative 2. And after I go left 2, I go up how far?
1, 3.
Go up 3. Yeah, there's 5 points there. I'm starting with the one that's on the far left. Okay, the next point after that, again, if I start at the origin, I go which direction first? Left how far? Left 1, which is a negative 1. And then after I go left 1, I go up 2, so that's a positive 2. Okay, I'm going to finish those out silently. You finish those out silently, and you can just look up at the screen to make sure you wrote down the points correctly. Make sure you look up and check to make sure that you and I have the same points. And if we don't, let me know. We'll figure out why. If you get that far and you want to work ahead on the domain and range, that would be great too. Well, 0, 0 would be where those black lines cross each other. Okay, and it's 1 below that. So it is 0 for the first number because it's 0. It doesn't move left and right at all. But it does go down 1. So that's why I have to have a negative 1 for my second number. I know it's right beside the O, but the O is where that is right where the lines cross. Okay, and that's 1 point down. So that particular problem did not have any repeats. How many more minutes you need? 1, 2, 0. This is fairly simple and straightforward as well. It's just one of those things you got to know. And this may be a little bit of a repeat, in which case, that just makes it all that much easier. Yeah. All right, number 2 is the first one we're going to look at. And it basically just says, determine whether each relation is a function and explain. We are going to explain. So number 2, copy down that chart. It's real fast. You don't have to make it a fancy chart. Okay. This is one of those moments where I'm more concerned about just getting a rough chart down on paper than I am about neatness in the chart. Now, the only reason they did a repeat here on the domain was because they were matching up each x with the y that it went with. Okay, they weren't going to leave a 6 here and then just leave a blank beside the 10. So that's the only reason that that's repeated. Now, it just says determine whether each relation is a function. So just write down the question, is this a function? Okay. I'm going to say this. Oh, Trevor?
I'm so confused about what function.
Well, I'm about to tell you. In order for it to be a function, nothing in the domain can be reused. I'm going to say that one more time. In order for it to be a function, nothing in the domain can be reused. So what would your first impression of this one be?
No.
It's not a function because the 6 gets reused. Okay. So let's write that down. So in case you forget 12 hours from now when you're trying to do your homework, okay, what makes it a function or not? We're going to say in order to be a function.
You said the domain cannot be reused?
Right. Nothing in the domain can be reused.
Is it like the only rule?
That is the only rule. When we have a graph, there's a different way to check that rule. But it's still the same rule at the heart of it. And if you think you might forget what the domain is, you can make yourself a little note in parentheses that say, no x's can be used twice.
So to find out if it's a function or not.
Make sure that nothing's reused in the domain.
That's it. Doesn't matter about the range at all. It's just the domain. So this one is not a function. We're going to say no, because the 6 from the domain is used twice. And that is your actual answer there is yes or no explanation. Look at number 6. This is where we have a graph, and it's not quite as straightforward. Okay, now I'm going to do a rough sketch of the graph. You can sketch yours like I sketch mine. Okay. I'm telling you, like, just literally sketch it like this. Now I used a different color for the actual graph part of it, not the axes, so I can make a point in a moment. Okay. For a graph, use the vertical line test. Which means I'm going to draw vertical lines all across this graph here without marking over my stuff. Kind of going back to what we said a minute ago, no x's can be used twice, okay? None of my vertical lines can hit my pink line twice, okay? So everything here just hit that pink line one time, which means it is a function.
Which means you hit it twice.
Do I now? Like this one line, I only hit that pink thing once. I drew my, like, upside down V looking graph. I drew that in pink. And so all of these lines here, every time I draw a line, it just hits the pink line once. Don't worry about the X and Y axis, okay? You're just looking at the graphed part. Tyler?
What else, like, the one on the lines, it hit it twice? And how would it,
Okay, I'm going to show you one that's not, and that'll help it make a little more sense. So this one is a function. Because the vertical lines cross once. If you look at number 10, no, not number 10. Yeah, number 10. No, number 8. Again, rough sketch. Draw my X and Y axis. And then there's like a curve, okay? Kind of looks like a C. Again, real quick sketch. It doesn't matter how neat it is at the moment. When you start drawing vertical lines across here, look what happens when you get over into the right side of this, okay? This vertical line crossed 2 times, okay? This vertical line crossed twice. So if it ever kind of like loops back over the top of itself, that's where you're going to run into trouble. So there and there, you can't see that very well. Right there, 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 there. Okay, all those things get you in trouble where those vertical lines hit twice. Tyler, did that help clear up what you were wondering? Are you just telling me what I want to hear? Or did it really help clear it up? Okay, just making sure. So we're going to say no because the vertical lines hit twice. That was very abbreviated, only because I'm about to run out of time. Okay, your assignment on page 43, you're going to do number 9 and 11. On page 51, you're going to do 1 through 7, odd. These are all odd. 21 through 27. Yeah. And that's it. All odds, yes.